In this video, we're going to find the area of a composite shape. When you think of the words composite shape, I want you to think of the word compound word. A compound word is made up of two or more words, just like a composite shape is made up of two or more shapes. The first thing that we're going to be thinking about in our minds is how to decompose this shape. Decompose means take apart. So how can we take this apart into shapes that we recognize and know how to find the area of? So over here we have this line, and that to me is the first thing that I notice, and it splits the shape up into, for me this looks like a rectangle, and then this looks like half of a circle, so a semicircle. I'm going to start with the part that I think is easier. Usually most people know the area formula for a rectangle, so I'm going to start there. And we need to find the length and the width. So I have the length here on the left, it says 12 centimeters, but I don't have this length at the bottom. It appears that I don't have that value. So I have to look at what other information I have. It does not say that these three sides, or four sides I should say, are congruent. So this is probably not also 12 centimeters. I mean, it could be, but I don't know. So I'm going to come up here and I'm going to look at the other piece of information that I have. And what I'm going to do is I'm going to go ahead and complete this circle as well as I can and try to make it look like a full circle. So I'm going to use a dashed line and try to help you envision this as an entire circle. Then from there, I realized that this is the center of the circle, and the distance from the center of the circle to the edge of the circle is the radius. So the radius of this circle is 6 centimeters. That piece of information is very helpful because if the distance from here to the edge is 6 centimeters, well, the distance from here to the edge is also 6 centimeters. This distance is also 6 centimeters. I want you to actually picture this arrow swiveling along this edge of the circle, swiveling down, and eventually resting on this dotted line. And this segment right here is equal to 6 centimeters because that's the radius of the circle. I could also picture swiveling this arrow to the left, each of these arrows being equal to 6 centimeters, and the other side over here is also 6 centimeters. Another way to think of this would be to say, well, if this is the whole circle, and this dotted line that goes through the center, then this length is the diameter of the circle. And the diameter of the circle is double the radius, so it's equal to 12 centimeters. Hopefully I talked about this enough that you understand that this length is 12 centimeters, which makes this length across from it also 12 centimeters. So I was wrong. I thought it was just a plain rectangle. It's actually a special type of rectangle. It's a square because every side length is equal to the same length. So now what I'm going to do is I'm going to find the area of the square. We use the rectangle formula for the square as well, length times width. The length was 12 and the width was 12 for this square. I multiply those together and I get 144 centimeters squared for the area of the square. So I'm going to come down here to my chart, and the first part on the left says type of shape. So we found the area of a square, and we found the area of that square to be 144 centimeters squared. So I write in 144 square centimeters. Then I'm going to move on to this half of a circle, which we also call a semicircle. And to find the area of a semicircle, you find the area of the entire circle, and then you just find half of it by dividing by 2. You just need the area of half of it. Next we need to find the radius, and we already determined that 6 was the radius, so I'm going to go ahead and plug in 6 for the radius. I don't want to forget to divide the area of the whole circle by 2, so I'm going to write the 2 next. After that, I'm going to think about what 6 squared means. 6 squared means 6 multiplied by 6, which equals 36. Try to recall that this power of 2 tells you how many times to record the base. You record the base twice. And I don't want to forget to divide that area of the whole circle by 2. And then finally, I'm going to type into my calculator pi times 36, enter, and then I press divide by 2, and I get 56.548667776. It just keeps going and going. So I decided to round this to the thousandths place because I didn't want to write that really long number out, and I know that in the end I'm only going to round to the nearest tenth. So this will give me enough decimal length that I can properly round to the nearest tenth at the end of the problem. So now I have the area of the semicircle. So I'll write type of shape. It's a semicircle. And then the area was 56.549 centimeters squared. And then to find the total area of this composite shape, you just add the area of the square to the area of the semicircle to get your total area. So 144 plus 56.549, I get a total of 200.549, which I'm going to round. I said we'd round to the nearest tenth, so that would be 200.5 square centimeters. And that is the total area of this composite shape.